Messier 31, better known as the Andromeda Galaxy, is our giant galactic neighbour, and because of our closeness to this colossal galaxy, we have been able to study it in extraordinary detail. Welcome to the Daily Galactic. Today we're talking about the Andromeda Galaxy and the intriguing marvels that lie within the swirling mass of stars and dust. The earliest observations of Andromeda date back to 964 AD by the Persian astronomer Abd al-Rahman al-Sufi. But it wasn't until 1764 that Charles Messier catalogued it as Messier 31 in his famous list of objects in the night sky. Found at a mind-numbing distance of 2.5 million light-years away in the constellation of Andromeda, in which the galaxy is named after, is the nearest major galaxy to Earth. Both the Milky Way and Andromeda lie within a cluster of galaxies known as the Local Group, of which Andromeda is the largest in both mass and size. But how did this galaxy form? Well, Andromeda's story starts 10 billion years ago, where it formed from numerous collisions and mergers of many different proto-galaxies. These collisions formed its huge galactic halo and its extended disk of stars. During this time of intense turmoil and chaos, star formation was running rampant. All these years ago, Andromeda would have been known as a luminous infrared galaxy for about 100 million years. Somewhere between 2 to 4 billion years ago, Andromeda had an extremely close run-in with Messier 33, better known as the Triangulum Galaxy. This also triggered lots of star formation across Andromeda's disk, its massive globular clusters, and even disturbed the Triangulum Galaxy's outer disk. Over the past 2 billion years, star formation in the Andromeda Galaxy has steadily declined, and now is believed to have decreased to the point of near inactivity. During the galaxy's evolution, it also had interactions with satellite galaxies like Messier 32 and Messier 110, and others that have been absorbed into the galaxy. These interstellar exchanges have actually formed structures, like Andromeda's giant stellar stream, throughout the galaxy. Another galactic merger, believed to have taken place about 100 million years ago, is thought to be responsible for a counter-rotating disk of gas and dust found in the center of the galaxy. Overall, Andromeda is believed to have around 1 trillion stars, roughly twice that of the Milky Way. How about the structure of Andromeda? In visible light, Andromeda has the regular appearance of a spiral galaxy. However, infrared data from the 2-mass survey and the Spitzer Space Telescope showed that the Andromeda Galaxy is actually a barred spiral galaxy, just like the Milky Way. Although both galaxies share this characteristic, Andromeda is much bigger than the Milky Way, with a diameter of 222,000 light-years. In comparison, the Milky Way is believed to have a radius of 105,700 light-years. Since we don't see Andromeda head-on, it's proven to be difficult to study its structure in great detail. It appears to be a fairly regular barred spiral galaxy, with 2 continuous trailing arms of stars, gas and dust that are separated from each other by a minimum of 13,000 light-years and can be followed outward from a distance of roughly 1,600 light-years from the core. However, because of its turmoil and violent past, there are distortions found all along the arms, with some other spiral structures being proposed. Astronomers have debated whether it could have a single spiral arm or even a flocculent pattern of long filamentary and thick spiral arms. By looking at it, what ring structure do you think it has? Let me know in the comments below. In 1988, the European Space Agency's Infrared Space Observatory discovered that Andromeda may be transforming into a ring galaxy. A prominent ring has formed at a radius of 32,000 light-years from the core that has been nicknamed the Ring of Fire. Sadly, it can't be seen in visible light because it's primarily made of cold dust. However, it's believed that most of the star formation that is left in Andromeda happens within this ring. At the centre of the Andromeda Galaxy is an extremely dense and compact star cluster. In this Hubble image, the stars are so tightly packed that it appears like a massive star surrounded by a diffuse bulge. The most accepted theory about Andromeda's core is that it features a double nucleus. The brighter concentration seen here is designated as P1 and is actually offset from the centre of the galaxy. The dimmer concentration of stars, designated as P2, falls at the true centre of the galaxy and contains a supermassive black hole. Many models have suggested that P1 is actually a condensed disk of stars that are in an eccentric orbit around the supermassive black hole found in P2. The eccentricity is such that stars linger at the apocentre, the furthest point of the orbit, creating a huge concentration of stars. P2 also contains a dense and compact disk of hot A-class stars. In redder filters they aren't easily seen, but when studying it in blue light or ultraviolet, they dominate the nucleus, causing P2 to appear brighter than P1. How P1 managed to achieve its remarkably eccentric orbit around the black hole is currently unknown. It's been suggested that it was the remnant of a smaller dwarf galaxy that was cannibalized by Andromeda. But such a nucleus would have an exceedingly short lifetime. This idea could be partially resolved if P1 featured a supermassive black hole at its centre, just like P2. But when studying the distribution of stars in P1, no evidence was found that a supermassive black hole exists there. Many galaxies feature globular clusters. They're ancient remnants of old stars made billions of years ago, and Andromeda features about 460 of them. The most massive of these is known as Mile 2 and is nicknamed Globular 1. It has a greater luminosity than any globular cluster found in the whole of the local group. It contains several million stars and is twice the size and luminosity of Omega Centauri, the brightest and largest globular cluster in the Milky Way. Some astronomers believe Mile 2 to be a remnant of a smaller dwarf galaxy that was absorbed at some point in the past because it has a variety of stellar populations with different ages and is way too large to be an ordinary globular. Just like the Milky Way, the Andromeda Galaxy has its own set of satellite galaxies. Currently, it has over 20 known dwarf galaxies. The most commonly observed are Messier 31 and Messier 110. Based on current evidence, M32 appears to have undergone a close encounter with Andromeda in the past. It may have been a much larger galaxy at one point that could have had its stellar disk stripped from it and assimilated into Andromeda's. M110 also heavily interacts with the galaxy and has had a stream of metal-rich stars stripped away from it and absorbed into Andromeda. Although in visible light, Andromeda appears massive, it's actually much larger than what could be seen with a telescope. Surrounding the giant galaxy is an enormous halo of hot ionized gas that acts as a reservoir of material for future star formation. This halo of diffuse plasma has been measured to extend an astonishing 1.3 million light-years or more from the galaxy. The Milky Way also features a diffuse gaseous halo, and Andromeda's reaches about halfway to the Milky Way, so is likely in contact with our own halo. On the topic of interactions between the Milky Way and Andromeda, both galaxies are moving toward each other at a rapid pace. Andromeda is hurtling towards us at a speed of 110 kilometers per second. Not to worry though, as this interstellar collision won't happen for around another 4 billion years. The outcome of this cosmic battle between the two galaxies will most likely be a huge merger of the two, where they will form a giant elliptical galaxy, or perhaps even a large disk galaxy. Collisions such as this are actually extremely common in various galactic clusters. What will happen to the Earth and the solar system when this happens is currently unknown. Before the merger actually happens, there is a chance that the solar system could be ejected from the Milky Way altogether, or even enter the Andromeda Galaxy before the merger. Thanks for watching. Leave a like if you learned something new today, and be sure to comment any questions you have about our amazing cosmos. Subscribe for more videos coming out very soon.